Hello everyone. Today we are going to be talking about adding and subtracting mixed number where we keeping them in a mixed number format, and the fraction part or the proper fraction part of it is not talking about the same fraction, or the denominators, so to say, are not the same denominators. What that means is we are going to have to be working with least common denominators to go ahead and get started adding the fractions. So before we go ahead and get started, some things to keep in mind when to add or subtract while keeping it as a mixed numbers. We align the numbers vertically. The way we write it makes a big difference. So to make sure that it's easy for us, we want to write it out vertically. You could also do it writing it out horizontally the way the question is given to us. But when we're actually doing the addition or subtraction, if we were to write it out vertically, it just makes it much easier. Second thing is to always add and subtract from right to left. That's one of the few things in our course that we are going to do opposite. We do this addition and subtraction of your whole numbers, of your mixed numbers, from right to left. And lastly, but definitely not the least, as a matter of fact, the most important point about this video is to make sure the fractions are like fractions. Now, before we go ahead and actually get started working with the addition, what I would like to do is start off by just kind of getting the idea of what really is happening with the two numbers we have, and then we'll go ahead and get started. So I've got two number lines drawn out over here. The first one per se is talking about a 15, and I'm going to go ahead and say this number line, I'm only capturing it between 15 and 16, and notice the fraction part of the 15 is talking about 5, 6 being the fraction of it. So what I'm going to do is I'm going to just, this is between 15 and 16, so I'm simply going to go ahead and move 5 portions over. I get a 1, a 2, a 3, a 4, and a 5. Out of the 6 equal portion, I only moved 5 over, and this spot is where my 15, 5, 6 is. So if we're trying to make sense of the numbers, this number is in between 15 and 16, but as you can see from the picture, it's much closer to a 16 than it is to a 15. So when we're estimating our sum to begin with, which is always a good idea to do, we can see that the number we're going to be thinking of is more in terms of 16. Now let's look at the second number. This number is in between 9 and a 10. And the fraction portion over here tells me it's 2/3. So I move 1/3 and I move 2/3. And just because of the nature of the number, this number is also closer to a 10 than it is to a 9. So guesstimating, my answer is going to lay somewhere in between a 25 and a 26. Okay? It could be 25 and some fraction, or 26 and some fraction. That's what we have a good guesstimate of. And then we're going to go ahead and actually work with it with the numbers. So to start off with, like we suggested, the very first thing we're going to do is write my numbers out vertically, so I can go ahead and look at them the way I'm going to be training my brain to do. Okay? Let's write these out. Now, we are starting to work on it from right to left, so we focus on our fractions first, but I really cannot add or subtract these fractions just now because the top one is talking about fraction with 6 equal portion, and you can see in here that I'm highlighting in yellow. Everything is in 6 equal portions, where the bottom one, I'm going to highlight that with a blue. As you can see, it's going to be only 3 equal portions. So they're not really equal to each other. And since they're not really equal to each other, the job we have is to make them equal to each other so we can talk about adding them in this case. I'm just going to picture-wise go ahead and draw me little lines here, so I can see how can I really make them even. And if I was to make them even picture-wise, I can divide them into 6 equal portion. And if you talk about the shaded region, now the shaded region is talking about this one, this one, this one, and this one, which is 4 out of 6. That's what I get picture-wise, okay? But it's not practical to do pictures every single time. So what do we do numerically? Numerically, the concept that says, hey, you know what? I have multiple fractions. I gotta get them to be the equal sized portions. I'm talking about finding a least common denominator. And the least common denominator between a 3 and a 6 happens to be a 6. Okay? Now, it's my job to take what I have and convert it into a 6. Looking at the first fraction, I'm good to go. The denominator is already a 6. Looking at the second fraction, since that denominator is not a 6 just yet, I need to upscale. Remember, upscaling is the process where I find a number that I multiply both top and bottom of the fraction with that same number. And remember, with the upscaling process, because of the fact that we're multiplying both top and bottom with the exact same number, I'm not changing the meaning. I'm not changing the shaded region. I'm not changing the portion, the interested portion. All I'm doing right now is making my numbers look bigger, i.e. making my portions look smaller. And if I can do that, I can approach my fractions in a format where they're ready to get added. Okay? So I get this, and guess what? Because I have the same fraction, I'm ready to go ahead and add it, and I get a 24 9 over 6. Okay? I'm going to bring that over here, and let's talk about 24 9 over 6. Do we think we can leave that as an answer? No, of course not, because your fraction is not simplified. So in this case, in my head, I'm going to think of a number that can divide both top and bottom. And once I get that divided by a 3, because 3 is going to divide both of them, I'm left with a 3 over 2. And let's rewrite so I can see what's happening. Am I done deal? Nope. Because if we look at our mixed number, something is a little bit off. In this mixed number, my fraction is an improper fraction. Remember, mixed number only talks about something which is in between two whole numbers. And if it's something in between two whole numbers, meaning it's something less than a 1, the only correct format of a fraction that can represent that is a proper fraction, meaning top being smaller than the bottom. So I have got to start focusing on this 3/2. On the side, I can come by and I can say, hey, 3/2 is the same thing as saying 1/1/2, which include your long division. And if I was to do that, I'm going to bring it out here, and I'm going to write it out as a 1/1/2. Now, in the name of simplifying, I made it look even more uglier. But hold on a second, because we can go ahead and work with it. Because it's kind of what we did in a previous video, where we have a mixed number getting added to a whole number. So the whole number parts of these get added. I'm going to kind of show it to you over here, because you have a 1/2 and you're adding something that doesn't have a fraction part. It's kind of like saying one person has 1.5 pizza, the other person has 24 pieces. So all together, the portion pizza is a 1/2, but full whole untouched pieces are 25. And that is the concept we're going to be using in here to get down to the final answer, which is in a correct mixed number format with the fraction being a proper fraction. And that's exactly what we had guesstimated when we were thinking about it, where we are saying, hey, you know what? My answer is going to be in between 25 and a 26. So this case where your mixed number comes out with a fraction being an improper fraction can only happen when you're adding two mixed numbers per se. And you simplify the fraction portion of it and add up the whole numbers. That only happens in an addition. The answer here is 25.5. Let's move on to the next question. Now, our question is about subtracting. So let's go ahead and start subtracting. But before we do the subtraction, let's kind of get the idea in our head as to what kind of numbers we're looking at. We are talking about a number between 15 and a 16 because the portion for 2/3 is closer to the 16. So let's guesstimate more towards the 16. And then the other number, which is a 9/3/6, which is exactly at a half. So you also guesstimate it toward the bigger number, which is your 10. So in estimating our answer, we're talking about something between around 26 minus, approximately 26 minus 10. So something around 16. So we know that, 15 minus 16 minus 10. So our answer is going to be in between 5 and 6. So that's going to be a mixed number, which is with a 5 and a fraction or something of that sort. So once we have that understanding, let's actually go ahead and start working with it. So we're going to go ahead and write our problem vertically. And when we do this, we come across the same situation as we did earlier. My fractions do not have a same denominator. So we are finding the LCD of a 6 and a 3. And as we remember from the previous problem, it is a 6. So we're going to go ahead and upscale the fraction that doesn't have a 6 as the denominator. You upscale it by a 2. And one of the other things I'm going to really suggest you all do is rewrite your numbers, because if there's a lot of a mess, it's harder to see things as compared to numbers that are easier to see when you have a clear picture here. So this is a very simple problem. Going from right to left, we can see that our fractions are 4/6 minus a 3/6. Both of those fractions have the same denominator, so I can go ahead and simply subtract the numerators, which leave us with a 1/6 for the numerator. 1/6 for the fraction part of it. And moving on to the left, you have a 15 minus 9, which leaves us with a 16. So we had guesstimated our answer was going to be between a 15 and a 16. We were just a tad bit off. It is 16 and 1/6. And again, with 1/6, we're much closer to a 16 in comparison to a 17. So our answer here is 1/6. So let's just reiterate what we learned in this video. When we are adding or subtracting mixed numbers with by keeping them in their format and not changing them into improper fraction, the first thing we do is write them out vertically. It's easier to see it that way. If your fractions do not have a same denominator, we find the LCD and upscale the fractions. Once the fractions are common fractions, then we're able to go ahead and add or subtract whatever needs to be done, finish the fraction portion, and then move on to the left to work with the whole numbers. Now, in an addition problem, we can end up with a situation like we did over here, which I'm going to just highlight, where we had something that was coming out with a mixed number and the fraction portion of it was in itself an improper fraction, and we get to simplify it, but we do not get that situation in a subtraction. Please make sure that you watch the next video to see what could be an involved case of subtraction of mixed number with borrowing. Thank you for watching.